In this video I'm going to show you how to write a complex number in polar form. This is what's known as polar form here, r cos theta plus I sin theta. And the way to convert your complex number into polar form is to follow these steps that I've written out here. You may want to write these down, they're quite helpful. So you start by finding a modulus, which is this number r. I'll show you how to do that. Then you find an argument theta. It's all the information you need for here, and you can fill those in. And you just do a drawing to check that you get the right argument, theta. So we'll start by trying to figure out what polar form actually is, where this thing comes from. To do that, we're going to look at polar coordinates. Polar coordinates are just an alternative way of expressing a position. Usually use rectangular coordinates. You go along by something x and you go up by y and you put a dot. That's position. Polar coordinates use an angle and a kind of length that we call r. Imagine you've got a length r, this line's r1 long, it's an angle theta. You define the end point to be your point. So this point is fully defined by this length r1 at this angle. Imagine you've got another point at an angle phi with a different length r2. That gives you that point. And you can think about it in terms of circles. You've got a circle passing through that point of radius r2, and you've got an angle, and you can, by varying phi, you can go round the edge of this circle of radius r2. You can change the radius. Say this circle is r1, and you can go round by theta and trace out all the points in that circle. So by varying the radius of a circle and going round all of the angles, you can get all of the points, an infinite number of points. So any point can be expressed using these two parameters. This is polar coordinates. And when we think about the circles, you can define any position on the circle in the rectangular coordinates, which is x and y's, to be x equals r cos theta and y equals r sin theta. And when you think about this, it actually does make sense. If you think about this point here, this is theta equals 0 on this gold circle. So we put theta equals 0 into this. Cos of 0 is 1, so x is just r. And sine of 0, you should know, is 0, so y equals 0. That point there is point r0. And you repeat this for any point on the circle, and it will convert between polar to your rectangular normal xy coordinates. If you remember, a complex number is written z equals x plus iy. So if you substitute this and this into your x plus iy, like so, x is r cos theta, that goes in there, y is r sin theta, that goes in there, you get this expression here, which is exactly the expression on the previous slide. This is your polar coordinates. And this can also be written in other ways. You sometimes see it as r cis theta, where the cis is just cos I sin, which is pretty unoriginal. Or you can just write it in an even shorter form, which is r at an angle theta. So we're going to look at how to find the modulus r. It's very simple, it just comes from Pythagoras. You get this expression here. If you draw out a point, there, it's quite obvious. You go along by x, you go up by y, and the length of this is just going to be this expression here. So if you had z equals 3 plus 4i, where this here is your x, and that there is your y, that's only the 4, not 4i, just the 4, that's your coefficient. So yeah, look there, just the coefficient of I is the value of y. So put that in here, you get 5, which is quite obvious. 3 squared plus 4 squared gives you 5. Now to find the argument, slightly more difficult. You've got same example, z equals 3 plus 4i, and the formula is tan theta equals y over x. Now always draw a diagram. Just plot the point, and it'll make sure that the value of theta is a reasonable value. So we'll work it out. You get tan theta equals 4 over 3. We take the inverse tangent. You get theta equals 53 degrees. Look back at the diagram. Does 53 degrees look like a reasonable angle? Obviously this is between 0 and 90. So 53 is quite possible. Right. So let's look at the ones where the diagram is even more helpful. Say you had a very similar example but with the negatives in here. So you get z equals minus 3 minus 4i. If you work out the argument, you get exactly the same answer as the previous question, because the minuses cancel, so it's just the same. That's 53 degrees. So if you draw it out like that, that angle is obviously not going to be 53 degrees. So you need to do a little calculation. So 180 plus 53 gives you 233. That does look like 233 degrees. So you've got 180 going round there, and then you've got your 53 degrees in here. Strictly speaking, the 53 degrees that you got would be a kind of reflection of this, so the line up there. So you would have got a 53 round there, which corresponds to that angle. You can also find the negative angle, which is going round the opposite direction, which is just minus 90 minus this thing in here. You got minus 90 going round that way, and you got to find this angle in here, which is just 90 minus 53, 90 going all the way around here, less this bit in here, which gives you that there. You just add that up. Remember, it's the negative direction. You get this minus 127, and these obviously add up to 360 all the way around, and you can express it using either of those, the plus or minus angle. It doesn't make any difference. So we'll do a full example to find the root 2 minus I root 2 in polar form. Exactly the same steps, and find the modulus as so, just your x squared plus y squared, and when you square something with a negative it just becomes positive, so you get 2 plus 2 square root is 2. And finding the argument, remembering to draw a diagram. The argument is minus 45, which is obviously this angle going round this way. Negative angles are going round like that. And you can also work out the positive angle, which is going to be 315. You've got 360 degrees all the way around, less the 45 degrees there. So you plug that into the r cos theta plus I sin theta, which is your expression for polar form. You get this. I've used the positive angle here, so the 315. And there's other ways you can express this. It's what's called Euler's identity, which is just r e I theta, which is like that. And then there's the very lazy short form, which is just the modulus at an angle. So that's how you write out a number in polar form.